The first time German engineers examined captured American military equipment, many expected to find complex machinery, hidden innovations, and intricate engineering worthy of a global industrial giant. Instead, what they discovered left them staring in disbelief. Beneath the dust of battlefields and the scars of combat was something almost unthinkable: machines designed not for perfection, but for survival. Tanks, trucks, and weapons built with a simplicity that seemed almost crude by German standards were somehow crossing continents, surviving brutal combat, and returning to the battlefield again and again. As the war intensified and Germany struggled with shortages, breakdowns, and endless maintenance problems, a troubling question began to emerge among some of its most experienced engineers: had America discovered a secret that Germany had completely overlooked? What made this discovery so unsettling was not just the appearance of American equipment, but the philosophy behind it. German engineering culture had long been rooted in precision. Every component was carefully designed, refined, and optimized for maximum performance. Complexity was not avoided, it was embraced as a symbol of advancement. A more powerful engine, a more accurate gun, a more sophisticated transmission system, these were seen as clear indicators of superiority. In contrast, American machines looked almost deceptively simple. At first glance, they appeared less refined, almost like shortcuts had been taken in their design. But the deeper German engineers looked, the more they began to realize that nothing about these machines was accidental. American military equipment was built around a single, brutal assumption: war would destroy everything, repeatedly and without warning. Tanks would be hit. Trucks would break down. Engines would fail in mud, snow, and desert heat. Instead of resisting this reality, American engineers designed around it. Panels could be removed quickly. Engines could be accessed without dismantling half the vehicle. Standardized bolts and interchangeable parts meant that repairs did not require specialized tools or rare components. In many cases, a damaged vehicle could be returned to service in hours rather than days. For German engineers, this was a completely different way of thinking. In their system, vehicles were expected to perform at peak efficiency, but often required highly skilled maintenance when something went wrong. A damaged transmission or engine failure could sideline a tank for long periods, sometimes permanently if replacement parts were not available. The emphasis had always been on building machines that were technologically superior on the battlefield, even if they were difficult to maintain in prolonged war conditions. As captured American equipment was transported back for examination, engineers began documenting these differences with growing concern. Reports described tanks that were easier to repair under field conditions than expected, trucks that could be maintained by relatively inexperienced crews, and components that could be swapped between vehicles without modification. It was not just the simplicity of design that stood out, it was the scale of standardization. Entire fleets of vehicles shared common parts, meaning supply chains could function more efficiently even across vast distances. At the same time, Germany's own industrial situation was becoming increasingly strained. Allied bombing campaigns targeted factories, railways, and fuel depots. Skilled labor was becoming scarce. Production delays were growing longer. Even highly advanced German designs began to suffer in practice because the infrastructure required to support them was breaking down. In contrast, American industry was expanding rapidly, producing massive quantities of equipment that did not require extraordinary conditions to remain functional. For German engineers observing all this, the realization was slow but unavoidable. They were not simply looking at two different types of machines, they were looking at two entirely different philosophies of warfare. One side sought perfection in individual design. The other sought endurance across entire systems of production, repair, and replacement. On paper, the difference might have seemed minor. On the battlefield, it was becoming decisive. And as more captured American vehicles arrived for inspection, the unease grew stronger. What had once been dismissed as simplicity now looked like a carefully calculated strategy, one that Germany had not fully anticipated until it was already too late. By the summer of 1944, the contrast between German and American engineering philosophies was being tested every day on battlefields across Europe. Following the Allied landings in Normandy, German forces found themselves confronting an enemy whose strength seemed almost endless. New tanks appeared as quickly as old ones were destroyed. Convoys of trucks stretched for miles. Damaged vehicles that German commanders believed had been permanently disabled often reappeared on the front lines days later. To many German soldiers, it felt as if the Allies possessed an inexhaustible supply of equipment. For engineers tasked with evaluating captured machinery, the mystery became increasingly important. They were no longer studying American equipment out of curiosity. Germany's military situation was deteriorating, and every lesson carried potential value. Teams inspected captured Sherman tanks, transport trucks, half-tracks, and countless other vehicles. The findings were often surprising. One recurring observation was accessibility. In many American vehicles, major components could be reached quickly without dismantling large sections of the machine. Mechanics could access engines, transmissions, and other critical systems with relative ease. This might seem like a small detail, but on a battlefield, where every hour mattered, it made a tremendous difference. Repairs that could take German crews an entire day sometimes required only a fraction of that time for Allied maintenance teams. German vehicles often reflected a philosophy that prioritized battlefield performance above all else. The famous Panther and Tiger tanks were powerful and heavily armed, capable of destroying many enemy vehicles at long range. Their crews often admired their firepower and protection. Yet these same tanks were mechanically complex. A damaged transmission, engine problem, or suspension failure could remove a vehicle from combat for extended periods. Even routine maintenance frequently demanded significant time and expertise. The Americans approached the problem differently. Their goal was not necessarily to build the most powerful tank in the world. Instead, they sought to build a tank that could be manufactured quickly, transported efficiently, maintained easily, and operated reliably under a wide variety of conditions. The Sherman tank became the symbol of this philosophy. German crews often criticized it for having thinner armor and a less powerful gun than some German tanks. Yet the Sherman possessed advantages that became increasingly important as the war continued. A disabled Sherman could often be repaired and returned to action rapidly. Replacement parts were widely available. Crews received extensive logistical support. Even when a vehicle was destroyed, factories back in America were producing replacements at astonishing rates. German engineers understood production figures, and those numbers were alarming. While Germany struggled to maintain output under Allied bombing campaigns, American industry seemed capable of replacing losses almost as fast as they occurred. The difference extended beyond tanks. American trucks became a particular source of fascination. German logistics relied on a mixture of vehicles from different manufacturers, captured equipment, and even horse-drawn transport in many areas. This created endless challenges for maintenance and supply. American forces, however, benefited from large fleets of standardized trucks. Parts were interchangeable. Mechanics were familiar with common systems. Supplies could be distributed more efficiently. On the battlefield, these advantages translated into operational flexibility. Allied units could move fuel, ammunition, food, and replacement equipment with remarkable speed. German commanders increasingly found themselves facing enemies who could sustain offensive operations for extended periods while maintaining a constant flow of supplies. Engineers examining the equipment began to realize that simplicity was not merely a design choice, it was a weapon. As the months passed, reports from the front grew more troubling. German crews frequently abandoned otherwise intact vehicles because repair facilities were unavailable or spare parts could not be delivered. Fuel shortages compounded the problem. Some of Germany's most advanced machines spent more time awaiting maintenance than engaging the enemy. The technical superiority that had once inspired pride was becoming a burden. Among certain engineering circles, quiet discussions emerged. Had Germany focused too heavily on building the best individual machine while America focused on building the most effective system? The question was uncomfortable because it challenged assumptions that had guided military development for years. Engineers who had dedicated their careers to pursuing perfection now watched as simpler designs helped sustain Allied momentum across Europe. The evidence became impossible to ignore after the Allied breakout from Normandy. American and Allied forces advanced across France with extraordinary speed. Roads filled with vehicles carrying fuel, troops, and supplies. Maintenance units followed closely behind, keeping damaged equipment in service. The logistical machine functioned with a level of efficiency that astonished many German observers. As Allied armies pushed toward Germany's borders, captured American vehicles continued to be studied whenever opportunities arose. The lessons were increasingly clear. Success in modern warfare depended on far more than armor thickness, gun caliber, or engineering sophistication. It depended on reliability, maintainability, and the ability to keep thousands of machines operating simultaneously across vast distances. For some German engineers, this realization came with a bitter sense of regret. They could now see the strengths hidden beneath the apparent simplicity of American equipment, but by then, Germany was fighting a desperate defensive war, and the industrial advantages that had once seemed merely impressive were becoming overwhelming. The true shock was no longer how simple American machines appeared, it was how devastatingly effective that simplicity had become. The final months of the war transformed these engineering lessons into undeniable reality. As Allied armies crossed into Germany itself, the nation's industrial system was collapsing under relentless pressure. Factories that had once symbolized German technological excellence struggled to operate amid bombing raids, shortages of raw materials, and an increasingly desperate labor situation. Rail networks were damaged. Fuel reserves dwindled. Supply lines fractured. Even the most advanced weapons became far less valuable when they could not be repaired, fueled, or transported where they were needed. German engineers continued their work under these difficult conditions, often witnessing firsthand how the realities of modern industrial warfare were reshaping the battlefield. Many remained proud of the machines they had helped create. The Panther and Tiger tanks were still feared by Allied crews. German artillery remained deadly. Advanced aircraft designs demonstrated remarkable technical achievement. Yet admiration for these accomplishments was increasingly overshadowed by a painful understanding that engineering brilliance alone could not compensate for strategic disadvantages. Throughout Germany, military workshops became crowded with damaged vehicles awaiting repairs that might never come. Mechanics searched desperately for replacement parts. Cannibalization became common, with damaged machines stripped apart to keep others running. A single missing component could render an entire vehicle useless. Every repair became a challenge. Every operational machine became precious. Meanwhile, the Allies continued advancing. German soldiers noticed the contrast every day. Roads leading toward the front were filled with Allied vehicles moving in seemingly endless columns. Trucks carried fuel, ammunition, food, medical supplies, and spare parts. Recovery crews followed combat units closely. Damaged vehicles were retrieved, repaired, and returned to service with remarkable efficiency. The system functioned like a giant machine whose individual components could be replaced without slowing the whole. For many German engineers, this was the moment when the true significance of American simplicity became fully clear. What had once seemed like basic design choices were actually parts of a larger philosophy. American equipment was never intended to win through elegance or technical sophistication alone. It was designed to support a massive industrial network capable of sustaining war across entire continents. The realization was sobering. Germany had often pursued excellence in individual machines. America had pursued excellence in production, logistics, and reliability. On isolated testing grounds, German equipment frequently appeared superior. But wars were not fought on testing grounds. They were fought across thousands of miles, under terrible conditions, by exhausted crews operating machines that constantly required maintenance and repair. As Allied forces approached Berlin, some German engineers found themselves reflecting on the choices made years earlier. They remembered design meetings where complexity had been accepted in exchange for improved performance. They remembered projects that demanded specialized manufacturing methods and highly skilled labor. At the time, such decisions seemed reasonable. Nobody could fully predict the scale or duration of the conflict that would follow. The war's final months exposed the consequences of those choices. Germany's sophisticated machines often required a level of industrial support that no longer existed. Simpler American equipment continued functioning because it had been designed from the beginning with practical realities in mind. It could be built quickly, repaired quickly, and replaced quickly. When Germany finally surrendered in May 1945, the battlefield debate between complexity and simplicity had effectively been settled. Historians would later study countless factors that contributed to the Allied victory: manpower, resources, strategy, intelligence, geography, and leadership. Yet among those factors, industrial design philosophy occupied an important place. Captured reports, post-war interviews, and historical analyses revealed that many German engineers had indeed come to respect aspects of American equipment they once viewed as unimpressive. The lesson was not that German engineering had failed. German engineers remained among the most talented in the world. Rather, the lesson was that engineering must serve the realities of war. A machine that performs slightly worse but remains operational can be more valuable than a superior machine sitting idle in a repair yard. In the decades that followed, military planners around the world absorbed these lessons. Reliability, maintainability, standardization, and logistical support became central considerations in equipment design. The experience of World War II demonstrated that battlefield success depended not only on what a weapon could do when functioning perfectly, but also on how easily it could be produced, maintained, and kept in service. Today, when historians examine the wreckage and records left behind by the war, they often find themselves returning to the same surprising conclusion that gradually emerged among German engineers during the conflict. The secret strength of American military equipment was not hidden inside revolutionary technology or complex engineering marvels. It was hidden in something far less dramatic but far more powerful: simplicity. What initially appeared ordinary turned out to be one of the most effective military advantages of the entire war. In a conflict defined by massive armies, enormous distances, and relentless attrition, the ability to build machines that ordinary mechanics could repair and factories could produce in vast numbers became a decisive weapon, and for many German engineers who witnessed it unfold, that realization was perhaps one of the most unexpected lessons of World War II.